Hi, this video is an introduction to logic gates. We're going to talk about some circuit chips and do some tests on them. The video is done in parts. Each part is a different test or an exercise, and each part will build on the last. A logic gate is a device that implements a Boolean function. Logic gates are basic logic circuits that take in one or more, typically two, Boolean inputs, perform a logical operation on them, and thus produce a single binary output. Logic gates are typically constructed with integrated circuit chips, also known as ICs, and their output values can be expressed with truth tables. A truth table shows all possible inputs of a logic gate and the corresponding outputs. In this experiment, we used 7 different ICs and connected them in circuits to find their types and their truth tables. The first circuit turned out to be an OR gate. That means that the power is on either when either button is pushed or both buttons are pushed. The second circuit turned out to be an AND gate, which means not a AND gate. The power is only off when both switches are turned on. The third case turned out to be an XOR gate, which means the power is on only when either toggle has been switched, but turns off if both are. In the fourth case, we had an AND gate, which means the power is only on when both switches are toggled. In the fifth case, it turned out to be an XNOR gate, which is the inverse of the XOR gate that we saw earlier. And in the sixth case, we got a NOT gate, which is the inverse of the input. And then finally we have the NOR gate. The NOR gate is the opposite of the OR gate and only has an output when no switch is toggled. NOR and NAND gates can also be combined together in certain ways to work the same way as different logic gates. This image shows different ways that a NOR gate can be put together to make different kinds of gates. And here we can see the outcome of these combinations. And just for good measure, here are some other examples with NAND gates. Now we move on to part 2, called addition, subtraction, and memory. ICs can be used to perform binary math by building specific circuits that contain different logic gates. These circuits are called adders or subtractors, depending on the action they perform on the input values. In this example, a half adder and a half subtractor were built. These are the most simple explanation of addition and subtraction with logic gates. And they produce two output values, sum and carry, in the case of the half adder and the difference, and borrow for the half subtractor. Both these circuits work only with two single bit input values. For the half adder, a XOR and an AND gate were used alongside with two LEDs representing the output values, sum and carry. For the half subtractor, the same ICs were used with an addition of a NOT gate. Now we come to the final part of this video, memory. Logic gates can be used to build memory circuits, of which the most simple example is the SR latch. The SR latch stores one bit of information which can be changed by different input values. This circuit is built with two NOR gates, and it takes two input values, set and reset. Two LED lights were used in the experiment to represent the output values Q and Q marked. JK flops is an example of a more complex memory circuit. The circuit is built with a specific JK flip-flop IC, and it's controlled by a clock, a push button. The JK flip-flop takes two input values, J and K, and returns two output values. Unlike the SR latch, this circuit can deal with situations of both inputs going high. 5 LED lights were used in the circuit, one representing the clock, 2 the values of J and K, and 2 the inputs values of Q and Q marked. And this marks the end of this video. I hope you enjoyed it. Have a nice day.